Now, is correlation always feasible? Now, what is correlation exactly? It is a statistical relationship between two random variables. I will not go into the intricacies of this. I will just use a simple definition. Correlation is a term or a concept that measures the strength and direction of the relationship, right? So what does this mean? Strength and direction of relationship between two random variables x and y. Now you know what are the random variables? These are nothing but just a box with any random values. So imagine if two random variables increases together. When it is 1, it is 2, it is 2, it is 3, it is 3, it is 4, it is 4, it is 5. So both are increasing together, right? So these random variables x and y will have a plus 1 correlation. In the same way, if the decrease, one increases and the other decreases. If y increases and x decreases, what is the correlation between x and y is minus 1, right? So the strength and direction of relationship, it is known as correlation. And its range is how much? From minus 1 to 1. Okay. And if there is no relation, the correlation is 0. Fine. So is it always feasible? The answer is actually no. A straight no. Why is it? I will try to better explain with an example. Imagine you go on a beach, okay, and on the beach, you met a statistician, and what he or she is doing, they are framing a relationship between the number of ice cream sold and number of shark attacks in the region. Okay, now imagine if it has a positive correlation. As the number of ice cream sold are increasing, the number of shark attacks is also increasing. So, will you infer from this that the number of ice cream sold is influencing the shark attacks? Like, will you? Never. It's quite ridiculous concept. How will the number of ice cream sold is increasing the number of shark attacks in the region? It's nothing. It's not feasible, right? But still, the correlation between them is positive one, which implies that if this increases, then it should also increase, or if this increases, it should also increase. So, what is happening here? This is a major flaw. I should not call it a flaw. It's an actual mistake that most people make, and this mistake is due to a term called causation. What you are seeing here is actually causation. When one random variable increases, the another also increases, but they do not have any direct relationship. I mean to say that there is a quantifiable relationship, but qualitatively there is no relationship. In correlation, this does not happen. Both random variables increases together, and one increase also influences the next increase. So there is a quantitative relationship as well as a qualitative relationship. So this is the difference between correlation and causation. There it is causation. One increasing, the other also increasing, but there is no relationship between them in actual life, in real life. And this causation is being caused due to a term called as latent variable, which is called a hidden variable. And what is this hidden variable here? The summer heat. Let me explain in a better way. Imagine number of ice cream cones being sold is increasing, right? What does this mean? That the summer heat is increasing, right? And as summer heat increases, what happens? More customers or more people coming to the beach, right? And as more people are coming to the beach, what happens? The probability of shark attacks increases, right? So this is not directly influencing this. But here you can see what if this is increasing, it is also increasing. But there is no direct relationship between them. This is called as causation. But and it is caused due to these latent variables, these hidden variables which we were not able to identify early. Summer heat, more people increasing, and this is called causation. But if you use the correlation between these things or these things, it is called correlation. So this is the difference between causation, correlation, and this is caused due to a term called as latent variables, the hidden variables. So I hope you cleared, I was able to clear it out.